Okay, yeah, I would get out and say like,
Oh,
I only take no smoking cabs.
I should have.
As they all should be.
I should have done that.
Okay, so what I wanted to introduce today is again sort of keeping very practical components. I want to introduce some things with building functions in AnyLogic. Something about why we do and something about how we do, and then talk about this notion of subclassing. Turns out that will be useful at two levels. One is you'll find ways, particularly in AnyLogic 7, that you may want to use this to spare yourself a lot of effort. But it will also help you understand some of the things that maybe some, what do you there, sure, okay, right. So I have some comments and sort of modularity, but fundamentally, if we when we're building a model often it has quite a bit of complexity associated with it. Complexity in just sort of building it, and there is a risk that if we're not careful with good hygiene in the model, care in building it, that it will end up overwhelming us. The complexity of where things are in the model, what things have to be changed when we want to change a need for use of the model, etc. You may find yourself just struggling with that at some point because the model is too large. And one way of managing this complexity is we make use of modular components. We sort of take components, we put them into separate pieces, and we achieve what's called a separation of concerns. We sort of may define a function, for example, that says is infective, and that will take care of determining if the person is infective. Maybe it's looking at whether they're in a certain state, maybe it's looking at whether a certain variable is true, maybe it's looking if they're in a combination of states, something along those lines. So often we will separate out sort of concerns within a program so that we only have to focus on one thing at a time. And this has a lot of benefits for building the model, for modifying it, for testing it, for understanding it, and for making it more clean, easier to sort of understand. Okay. I'm going to, it turns out that often we can do this in a way that's quite general as well, so we can reuse code. So one of the biggest ways that we can do this is by defining functions. Okay? We define functions within our model, and we use them for many places. Okay? So we may define a function that, for example, asks, we could start with a function. Imagine if we started with functions that asked, for example, is age category 0 to 4, something like that. We could have a function that calls that basically we call it on an agent, a given person, call it P, and it determines whether or not they're in age category 0 to 4. You could do that, right? And we could call that within statistics for a population. We could say count the number of people for whom this is true, in which case this wouldn't be P. We want to use it in statistics. It would be item dot is age category 0 to 4, right? Item dot is age category 0 to 4. We could have a different function, and having this sort of thing here might be quite desirable. I should just note, if we had that method, if we have this as a function in AnyLogic, that would confer some benefits. For example, we might decide to store people's age as a variable, and in which case this would just check if the variable's in 0 to 4. We might alternatively store their age as a call to a function, and we want to ask, compute using that function whether in 0 to 4. We might store it with a state chart as to what age category they're in. There'd be 0 to 4 is the first one maybe, and then 5 through 9. And all of that will be hidden by this function. When we use this in the statistics area, we don't have to worry how it's actually accomplished. We just call off to it, and if we end up changing from a state chart to a variable for age, or we change to a function for age that subtracts the time they were, subtracts the current time, the time they were born from the current time, and determines their age from that, then it doesn't, we could use any of those techniques. All we have to do is change the function. We wouldn't have to change where it's used. And this might be used many places within a model. So we can do this. We could also have another function called item.isAgeCategory 5 to 9, and we could do that. And we could have many such functions, but it gets a bit tedious that way. It would be much better if we could just say is in age category instead, is in age category, and pass it the name of an age category. Maybe we pass it ages 0 to 4. Maybe that's defined as an enum value, and it would return the number, or return true or false. And then maybe we'd have another one. We'd have a statistic called, count in youngest age category, and we'd use this as part of that. So this would be an example of a function that takes no parameters, is in age category 0 to 4. It does some work for us. It doesn't need any information to do its job. It has all the information it needs. All it needs to know is it's this current person it can check. This later one is in age category ages 0 to 4. Here it needs to know what age category you want to know about. You want to know about, are they in age category 0 to 4 or a later one? So here we talk about this function having a parameter. It takes a parameter that says, what age are you interested in knowing about? I apologize, it's the same. The terminology parameter there is just very well established, and it happens to overlap with AnyLogic's parameters. But here we're talking about information it needs to do its job. So this function can accomplish its job if you give it this information. Okay, so here we can define a function to accomplish that. So a function might, for example, compute a value. By the way, we would call this function a method because it operates on a person, it operates on an object, an agent, for example. And so it's also called a method. This might compute a value, for example, compute true or false. It might test some condition, ask if they're susceptible. It might perform an update. So you might say, item perform birth or something like that, and it actually performs a birth within the model. It might also return like its name, for example. Return some information about the person. Return the age category that they're in, or what have you. Okay. I think I'm going to avoid looking at that, but I want to look at a model. For example, here's a model that has some functions associated with it. Some of these are of the sort we've seen here, like is current smoker. So that's will return a value, true or false, depending on whether they're currently a smoker. Another one, count contacts. That returns the number of contacts that they have. How many contacts does this person have? That could be returned. Now, that could hide the fact of how many, do you have a separate network for friends and family? Do you have, maybe you have the link to your mother distinct from all other links? Count contacts, which might count all of those. And it would hide whoever uses that from having to worry about the vagaries of how things are actually implemented within this agent. We also might have other functions that are used internally. For example, what's the smoking initiation hazard ratio for the current person's age, or something like that. So we might have additional functions that are used for various purposes. So here we can associate functions with a person to perform some sorts of calculations. If we open up this model that we've mentioned before, in which Carmel
I was so happy to hear she said she has benefited from. It's called a model with birth death. So we'll open up here and with example models, ABM model with birth death here, and you'll find this model. Oops. Okay, fine. You'll find that this model has in it quite a few functions as well. So, for example, within person, in the function area, we have a set of functions associated, for example, with their current age, whether or not they're infected, something to ask them to perform birth, something to request a random age or what have you, get their name, report their children, report all the times infected for them historically, etc. So here, we've chosen to define functions in AnyLogic. The way in which you do that is by dragging a function in to the appropriate agent. And in order to do that, sometimes you'll find that you'll require information for it to do its job. In other cases, there's no information needed. So, for example, current age, that function can do its job regardless of. It doesn't require any information to do its job. Instead, it just computes the initial age of the person when they were first created plus the current time minus their appearance time. So maybe they were created at the beginning of the model as being 20 years old. Maybe it's now 10 years after that time, and therefore they're 30 years old. Okay? This would be an example of a function that doesn't require any information, in other words, in parameters. Now, this function consists of several pieces, as defined through the AnyLogic interface. So obviously it has a name. It has a return type, which is the type of information it gives back. In this case, it's giving back an age. That's a double precision quantity. Okay? And there's something somewhat more advanced here called static, which indicates whether it applies for a given person or whether it's something just about the person class. It doesn't depend on a particular person. Maybe, for example, something about fertility rate for different ages. That doesn't depend on a particular, it's a population-wide quantity. It doesn't depend on a particular person, so you might define that as static. But it's still associated with personhood, so we might put it in here. Finally, there's something called default, which is whether it's allowed to be used from outside this outside person, for example, whether name can use it. So these return types are things that we've started to talk a little bit about before. Methods or functions return values of different sorts, and there's one called void. Void means it doesn't return anything, it just accomplishes something. So you'd have void, for example, that did something. So perform birth, for example, I can't remember if that actually returns something. It may return the babies. No, it just does some job. It performs birth. There's no reference to the baby returned. By contrast, something like get person name, this returns the person's name as a string. This is quite a bit of value to be able to have something like this. You may ask, why do we need this get person name? It's to hide, it's so that people else using this from elsewhere in the model, or even using it within person itself, just don't have to worry about how it's stored. You don't want to have to worry about all the details of how these things are maintained. For example, is it looked up in some general table? Is it based on some ID? Is it based on an explicit name that's already there? So creating functions simplifies our lives because it decouples sort of the user from having to worry about all the details. Okay? This is a very important issue as your model grows. So that people who use it don't have to worry about all the details of how it's done. It's decoupling the what from the how. Okay? So, for example, someone outside person, maybe in name, shouldn't have to worry about whether there's several levels of infected or not. For example, whether maybe there's infective diagnosed in the past 30 days and infective, that's yet undiagnosed. We might just want to ask, is infective, and that will return, if it's in either of these states. The fact that we've called that in a method means it will continue to work even after we've changed these states, as long as you remember to change the method. As opposed to a situation where all over the model it's counting the particular state that you're in. That's not going to be robust, counting the particular state. So we build these functions to protect us from change. We build the functions because it's easier to think about. We don't have to worry about all the details. So here we have a wide variety of functions. These functions can be called from within here, and most of them can be called, I think all of them in fact here, can be called externally as well. Some of them are just little utilities. For example, this report children just iterates through the children. Well, maybe you can tell me what that does, if you can look at that. Here's a bit of code for you. What does this code do, do you think? So what does this mean? Remember this for loop? What is p child? Okay, good. It's a name. And it's a name for each successive child. This is a p mean person, sort of like a person, okay.
So is children is it a population name, or is it been assigned as a population?
It's actually a collection.
Or it's just a collection?
It's the collection that lives within persons. So if we were to click on this, we could see that each person has a set of children associated with it.
I see.
Where is it? Is it? Oh, there it is. Children, right?
I have a question about the P child, and where does that name, do you just find it in a case or?
Nope.
When you say person P child?
Yeah. I mean, I could call it, probably for this audience, I just call it child.
Right.
Just call it child. I think that's probably cleaner to do. Yeah. So there's a naming convention which uses the first letter to kind of denote what sort of thing it is. But I think in this case I'm going to just call it child. It was also partly to distinguish between that and so-called iChild, which is the index of the child. So in other words, are they child 1, 2, or 3, or 4, or what have you. This is like my child number. This has population location, and it says sort of where they are in the population. Current age, has person name this, and is currently either dead or alive. So let me put this down just to give you practice for reading these things. I can, by the way, in Java I can put these things in multiple lines. That's fine. So help me understand what's going on here. What can you help me parse this? So what's going on? So we have this collection. What is child? And it's each successive person. So this code here below it, within the so-called within the for loop, in these brackets, curly brackets, that's going to be run for each child, with that child being referred to by this thing, child. Now, what is the first thing this does? What is it computing? What is this sort of thing here where my sort of mouse is?
So the Boolean will return either true or false for whether or not the child has died.
Yeah.
So you'll either get a true or something.
That's right. Now I've done something that's pretty unhygienic here. What have I done? Well, I've gone in and I've had to deal with this. This is really, as far as I'm concerned, it's sort of bad practice. Really, what I should be doing this is alive or is dead or something along those lines. Like is not, okay, so what would that mean? Do you remember what a pound sign? Not.
Not alive.
So, okay, they're dead if they're not alive,
Yeah.
right? And then, okay, what am I doing? What's this thing here? Print that. And then, okay, so this is the first part of what it's printing. What's the plus? Concatenate. It just puts it together with that. So my child number, like 0, has population location. What do you think this is? Child.to string. It actually just turns them into, it's AnyLogic's sort of name or sort of rendition of what that child looks like as a string. In other words, given that we have a reference, it turns it into something. And in this case, it will say something like population, square bracket, 7, or something like that in the bracket. Okay, and has current age. What is this? Exactly. And, or it's actually a method, it's a call to a function. And person name, child.get person name, and is currently, okay, this is child dead, dead or alive. What is this doing?
So it's asking, it's like a loop statement.
Yeah?
So, is child dead? No, then it's alive.
Okay, so if it is dead, what is this expression gonna turn into? What value will this expression evaluate to, as we say? What will be the result of this expression if is child dead is true?
Okay.
It'll be the quote, the string dead, otherwise it'll be the string alive, and that will be appended to this. So in other words, concatenated, right? So that turns into a value and it gets concatenated with these things. Okay. So that's great.
And then, so your iChild, then is that supposed to go to the next child? Or it says iChild plus plus?
Oh, so all that is, I'm just counting each successive child, like child 0, child 1,
Right.
child 2. And so I started at child 0, and now that I've done all this, now I'm going to go up to child 1, and I'll do it again, and child 2, and do it again. And that's sort of one way to do this. Okay, so
The I on those, I mean, can we put an I in front of any name? Like sometimes we label person P.
yeah,
So we just say IP.
well, the
Why
yeah,
I?
why okay, I is used by certain, it's purely convention. It would work just fine if you left that out. Pretty much any name could have been done. Some people will probably name this child or child
Oh,
number.
I didn't see you labeled it by parents, actually.
I just labeled it by child. And the reason is because it's an index. So I want to communicate like this is holding, functionally it's holding an index. Something goes from 0 to 1 to 2 to 3. And when certain people see that, they'll say, oh, that just means it's going from 0 up. And so it communicates something about how it's used. Does that make sense?
And then you're adding one at the bottom to it and then starting.
Exactly. And the last time through here, this isn't going to matter because it's not used again, but that's fine. That's fine. Does that make sense? Okay. Now you notice that I just created this thing called is alive. Let's go define that. So let's go see how to define is alive as a function. Okay. I'm gonna stop.